20 years, an hour and a half like that. I need a quick show of hands as to how many people expect to be there in lab this afternoon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26. So did that include McCandless, Morin, Jones, Palmer, or Price? No? Well, it's 6 to 1, half a dozen to the other. I'm stuck either way. We're 27 and 28, and you would make it 26 in the Friday class. Why don't you stay in the Friday afternoon class then? Okay?
I can.
Now you want to move from Friday.
I think I was registered for the Monday class. You know, I didn't call.
No, not listed. Anyway, well, I'll just have to arbitrarily cut because we have only 17 on Friday morning. We already have 27 on Friday afternoon. I don't propose to put 30 in Monday afternoon. So somebody is going to have to move from Monday afternoon back to Friday afternoon. And I'm just going to cut it off arbitrarily. I'll have to warn you about that. I know it's very nice to ski on the weekend, but Friday is just as good as Monday according to the schedules of the university. So we will cut back to make the Monday section not larger than 26 or 27. There's only about 70 people here, so that should work out very well. Now, at the end of the hour last time, very quickly, and excuse me, one more point. The Friday 2 to 5 people who signed up, the 27 who signed up, can get their cards. The other people will get their cards in the laboratory this afternoon. And I'll give the cards out so that I don't get mixed up on anything. We stopped very abruptly on some of the external factors influencing sensory evaluation. Smoking, which is probably not important. Experience, which is very important in providing a frame of reference for the judge, in knowing, and also with knowing what to look for. The fact that we may change our standards with experience, that is, what we like at one period we may not like at another period. This is a very real problem. For example, in recent years there's been a large increase in the amount of wood aging of white wines in the Napa Valley and some other places in California. At first, some people loved the woody flavor. And then when the public began to recognize it as a woody flavor rather than a white varietal flavor in the wines, they got a big consumer reaction against it. So with experience with the woody character, people turned against it. And now the big problem is how to get the wines aged without the woody character. Chile is an example of a country where the whole country has had a changed standard. Within 100 years, it has gone from French standards on white wines to Chilean standards on white wines, which are completely different. The normal Chilean white wine is an oxidized white wine, rather dark in color, brownish in color usually, and rather high in acetaldehyde, sort of like an unbaked sherry or a non-floor long-aged sherry, and exactly what they are, as a matter of fact. Why this change has occurred, we don't know, but it occurred over a long period of time and now represents the Chilean standard for white wines. The time of day, I said last time, we don't know how important it is, but most people believe that we should do our judging of wines in the morning period. However, in the only full-scale test that I know that Pangborn, Berg, and Webb did some years ago, out of 8 tasters, only 1 got better scores before lunch than after lunch. In other words, was more sensitive to odors. So that doesn't look like that before lunch is any better than after lunch. On the other hand, the experts are almost completely in agreement that you're better off, I think because we're usually satiated with food after lunch and not able to concentrate as much on another sensory experience. But in an actual odor experiment where we were getting thresholds of odor, we certainly did not find that to be true. Memory, well, if you can remember things, that gives you some idea of how it occurred, in what framework it occurred at an earlier stage. And that's a very important factor. if you don't have any memory for odors, you're going to have some difficulty. You're going to have to go through the whole learning sequence each time in trying to figure out whether the odor is normal or abnormal and how normal or abnormal it might be. Some years ago, it was necessary for a neurophysician to test for odor sensitivity in each nostril. And in developing this, he found that by having people concentrate on thinking of the odor that they were looking for, that they could detect the odor at a lower concentration than if they were not concentrating. And the test had some built-in methods of not allowing guessing to go on, so that I think it is correct that if you concentrate on thinking of a certain kind of smell and look for it, you will be able to detect it at a lower threshold than if you're not. Psychologists have proven this with educational kinds of things and so forth, and so that's probably a true statement. Motivation is certainly true. You can get very much lower thresholds with animal experiments by paying them back in food, or with human beings by paying them back with praise, or paying them back with, we used to give them bottles of wine in order to motivate them, or time off is a very good one, or actual pay. And in most cases, the prestige of scoring high is a very big motivation also. Anybody should be able to taste. I can taste as well as anybody else. And so you'll find a great competition for people who are on panels trying to do the very best they can. You can stimulate the motivation by posting the results. That always stimulates people to do better. You can show that once they have a low result posted, that they'll work much harder the next time. And vice versa, a few people will get discouraged if they see they're getting low scores and will simply give up on the whole tasting idea, not think it's worthwhile. We recommend for just normal winery experiences that time off is probably as good a motivation as any. You take time to go to the tasting room, you take time to go back, you're away from your set routine of whatever you're doing. On the other hand, other wineries just have a period in which the tasting goes on every day and it's considered another part of the job. And last one has to do with adaptation. We are all variously sensitive to adaptation, and I can't give you any clues as to which is the number that you should be able to judge. With tomato juice, as many as 56 pairs have been done with no indication of diminution of sensitivity on the 56th pair compared with the first pair. So we would have to say that adaptation for pairs of tomato juice was very slow in coming. SO2, however, is a cause of decreased sensitivity because of its effect on the olfactory system, and therefore on white wines it's quite frequently impossible to proceed very far without having adaptation occurring and decreasing sensitivity. I find sparkling wines also to be very fatiguing, and it's almost impossible to do more than 5 or 6 sparkling wines with any degree of sensitivity at all. You find yourself overlooking a lot of points of interest in sparkling wines after 5 or 6 samples. The easiest samples probably are rosé wines and normal red wines. However, if the red wines are very young, you fatigue for the bitter taste. And pretty soon you'll have wines that are almost like quinine, and you're saying that they're soft red wines, and they're actually not. So you just have to discover for yourself with the samples in front of you and your own experience whether or not you think fatigue is a factor in the panel that you're working with, or for yourself. Usually whoever's directing the test will have to make some internal determinations of whether or not the panel is doing worse on the 5th set than it is on the 1st set. If it shows a diminution of sensitivity, the results are much less clear on the last set than the 1st set, he'll have to stop the determinations earlier. I should have said one more thing. There is a warming up period for sensory examination of wines, and that's not listed on your outline, but most often, and this is generally true in sensory evaluation, we give the first test and disregard the results. You're quite frequently have lingering tastes from lunch, from the candy bar you just had. Your mouth is very sensitive to acid after candy bars and so forth, so that we most often in sensory evaluation, particularly very accurate ones, we throw away the first samples and simply don't look at the results at all and just call them warming up samples. Now, we are going to take up difference tests, ranking and scoring today and Friday. This is a slight change from your lecture outline. Those of you who've been to laboratory already have a lecture outline. The rest of you will get it this afternoon. The lecture on sources of information will be given next Monday instead of today. So that's the only change I hope to make in the series of. The reference in the ASTM, Basic Principles of Sensory Evaluation, the first reference is not in the Enology, in the Winkler library yet, but will be shortly. And it's the only copies on the campus. They're not essential, these two ASTM publications, STP 434 and 433, but they do contain useful information which will supplement the basic references for these lectures this week from the Amerine, Pangborn, Roessler. If you look at your previous outline, you'll see what APR means, and ARF, Amerine, Roessler, and Filippello. First thing to distinguish is the two basic types of sensory evaluation that we will be doing in this course, and which you will be doing under winery conditions also. In many cases, we're only interested in determining whether there is a difference, any difference. We don't care what the difference is. It's sweeter or it's less sweet, it's gassy or it's less gassy, it's got more Cabernet or less Cabernet, it's got more acid or less acid, it's more astringent or less astringent, and so forth. It's more filter smell or less filter smell. It's been more oxidized by filtration or less oxidized by another filtration. There are all kinds of experiments of this kind in finding the best fining agent, the best filtering, the best processing arrangement for the wine, whether to freeze the wine at one temperature or another temperature, or cool it at one temperature or another one. And these we call pure difference tests. We're just looking for difference. Now, there is another kind of test which we are quite often called upon to do in the wineries, and that is a qualitative type of thing which has to do with quality. How much is this one better than another sample, and how much better is it than another sample? And these require two different kinds of tests. They are not the same. They do not. You can use some of the tests both ways, but I'm going to point out in a few minutes that it's better not to use one of the difference tests for quality test if you can help it. Now, the general problems are quite clear and quite easy to understand. Everybody has to understand the test. There's nothing worse for somebody doing research in sensory evaluation to find out that one part of your panel is judging the wines one direction and using one set of standards, and another part of the panel is using another part of the standards, and still a third part of the panel doesn't know what they're using for standards or are constantly changing. One day they're all color-minded, the next day they're all taste-minded, the next day they're all odor-minded. And so that you have great difficulty in getting any repetition of your results. The next two I've already taken up about the time of day and the number of samples, but coding is another methodological problem that many wineries do not observe, and I think quite frequently they prejudice their results. The use of A, B, C, D, E, F is absolutely impossible for anybody who's ever been at the University of California. The F samples will always score lower than the A samples, just automatically. You can say that that's foolish, but I can prove it to you. A class of this size, I could demonstrate it very readily. You would, even if you were trying to say, I won't be influenced by it, you will be influenced by it. It's just impossible not to be. You say that nobody believes in 13 is an unlucky number. We'll just try and use 13 on scorecards, particularly in consumer tests, and you'll get low results, almost always. I've never tested 7 and 11, but for a modern, knowledgeable college people, we might get some interesting results on that. So you code with 2-digit numbers or 3-digit numbers above 13. And we usually use above 20. And the numbers should be randomly selected. You will be surprised how often it is possible to have somebody come up with coded numbers and have duplicates in the same set or series. Or they will tend to put them in the same order again, even though they don't realize what they're doing. So it's better to draw the numbers off of a sheet of random numbers that have been developed out of some sort of computer. It is quite essential that you do not use the laboratory as a place to do the sensory evaluation. Any place almost is better than the laboratory. And the winery itself is a very poor place to do the sensory evaluation in, because the winery has its own built-in odors of various kinds, to which you will become fatigued, and which may be odors that are present in the wine that you have under investigation. So some sort of air-conditioned room, or if nothing better, an empty porch in somebody's house or something like that. The best thing is a dentist's spittoon to get rid of the samples, but we don't have enough dentist spittoon to fit around the whole class of this size, so we will use actual spittoons, which are bad because they have warmed up wine in them, and they will begin to give their own odors to the room, which will again interfere with the sensory evaluation. In spite of the interference of the noise, we will turn the air conditioner on in the tasting room, which we didn't do last time because you were just using water solutions, in the actual tastings, and you will get accustomed to it quite soon. And the last thing has to do with, you use anything between samples. Cheese, bread, crackers, water, apple juice, tomato juice, pieces of apple, and so forth. The psychologists say let them do anything they want, that they're better off if they have a free choice of methods of cleaning out their palate from one sample to the other. Some people, it doesn't seem to make any difference whether they rinse their mouth with water or cold water or warm water, or whether they use a cracker and so forth. We believe on some psychological grounds that it's probably better to just give them water. In the fact that cheese will cause you to lose your hunger and you may lose some sensitivity, although that can't be proven, we still feel that it's better not to give them food during the test. If anything, give them an unsalted cracker. That's about all. I think French bread is not as good as an unsalted cracker. But if they want unsalted crackers and that's the only way they'll perform, well, for goodness sake, give them an unsalted cracker or whatever they want. The point that you want is to get them to jump through that hoop and give you the results that you particularly want. Now, the next part is on a number of different true difference tests. And normally we do not use these, or we're not interested in using these for color and appearance differences. It says to cover up the samples if there are color differences. Well, that's also true if there are appearance differences. Suppose that you have two samples of Cabernet, one of which you have reason to believe is much stronger in Cabernet smell than the other sample. And you ask the people to evaluate of the two which is the higher in Cabernet odor. Well, if one sample is cloudy and the other is not, they will very soon associate the Cabernet odor, the lower or the higher, with the cloudy sample. And from then on, they'll get all the same result. It may be the wrong result, it may be exactly wrong, but you'll soon find yourself with a bunch of results. The cloudy sample is the one with the high Cabernet, even though it may just be the opposite, but they know that the cloudy sample is associated with something. They don't want to make a liar out of themselves, because they've already admitted on the first test that the cloudy sample has the high Cabernet. So they'll continue to repeat that result back to you every time if you let them see the cloudiness, because the cloudiness is something they can see and put their hand on. I've had people almost crying come to me after a series of tests and say, oh, we made the wrong decision at the start. It's the one that's not cloudy that has the high Cabernet odor. And we should have started that way. But once you start, you see, you have to continue if you think you're an honest taster. So what we recommend is that the samples all be made similarly brilliant. or that if they do have color differences or appearance differences, which you can't cover up, that you then serve them in black glasses, that is, glasses that are painted black on the outside. This will have glass next to the wine, so there will be no taste from the paint, and the paint rapidly dries and doesn't leave any smell anyway, and they can't see the appearance of the wine or the color. However, this motivation to succeed is very strong in human beings, and they'll cheat on you. They'll take the sample, and as they spit it out, they'll look with their eye over here and see what color it is in the spittoon. And as soon as they find that it's a certain color that goes with the high Cabernet, then all they do is look at what they're spitting out. They don't smell anything anymore at all. They just look at what they're spitting out. We tried to get around that by taking copper screens and put over the spittoons so that they couldn't see under the copper screens. And in spite of that, they would look at the liquid as it came out of their mouth before it got to the spittoon. So if the color differences are too great, you're out of luck, unless you color the wine with some innocuous dye. And in some kinds of experiments, I think that might be the thing to do. It isn't proper to blindfold them. Blindfolding them seems to do something to their sensitivity. And unless you train them to taste blindfolded, you can't put that in the middle of an experiment. You could lower the light somewhat, and that doesn't seem to interfere, or you could use a light which was the same color as the wine color, and this would tend to cover up differences. In experiments on the effect of different fungicides on vegetables and so forth, where the fungicide itself has made a difference in the color of the product, it's quite often that for carrots, for example, you have a very brilliant orange light, and whether there's a little difference in the orange color of the carrots or not, nobody can tell that difference. We've raised the objection, however, that nobody's proved that it might not have some subtle effect on the people. It might make them a little less sensitive to the difference you're looking for. So I think that as far as wines are concerned, it might be better to find innocuous dyes to add to the samples. Since they're not going to swallow the sample anyway, you could use almost any kind of a dye. Well, the easiest test, and the one that's most commonly used, and the one that most of you will be exposed to starting Friday, will be a paired test in which two samples are given, coded with some two-digit number, and the question that's asked in this type of test is, which sample is the higher in some named specific character? Which of the two samples, 32 or 74, is sweeter? Which of the two has more acid, and so forth? Since it's a paired test, the probability of getting the correct answer is a half, because you could choose either one of them, and only one of them is higher in acid, or only one of them is sweeter. So 50% of the time, you are going to get the correct answer. And so if you do this a large number of times, let's say you do it 100 times, you'd expect them to say, and they were just guessing, 50 times they would say that 32 is the sweetest, and 50 times they would say that 74 was the sweetest. In that case, there would be no difference, and that would be the answer to your question. Is there a difference between the sweetness of 32 and 74? And if they got 50-50, there is no difference. Now, it won't come out that way most often, because if there is a true difference in sweetness, let's say this is 1% and this is 1.3%, there is a difference in the samples. And so you'll get results from different tasters of varying, if they repeat the experiment varying numbers of times, in which this will perhaps be 40 and this will be 60 for 100 tests. In 60% of the times they will say that 74 is the sweetest, which it is, and in 40 times they will say that the other one is the sweetest. Now, there are a number of ways of determining which the statistical odds are that this result is due to chance or this result is due to a real difference between the two samples. And you want to know what the odds are. In biological guessing games, we like odds of about 1 to 20. That is, we want to be right 19 times out of 20. That is about as much as you could expect in normal biological testing. But in many cases, you want odds of 1 to 100, and you may want odds in some experiments of 1 to 1,000. In this case, we say that P is 0.5, or P is 0.1, or P is 0.01. Now, there are two tests given in the Hilgardi article, which most of you already have. The first test is a test calculated into charts. And this is the one that you will most often use, because all you have to do is look at the chart for 100 samples, 40 in favor of one and 60 in favor of the other, and you will be able to tell what the probability of that is by chance, or whether there is a real difference between the samples. And the probability will come out somewhere in this area here, and it will give the odds in those charts in the Hilgardi. You may get stuck in a dark and dreary place in the mid-Atlantic sometimes, in which you don't have a Hilgardi in your back pocket. And so then you've got to do this test all by your lonesome. And so then you could calculate chi-square very simply. Chi-square in these kind of testing and paired testing of this kind that we're doing is the number of judgments that favor one sample minus the number of judgments that favor the other sample minus 1 squared divided by n, the total number of samples. So in this particular case here, it would be 60 minus 40. This minus 1 is not very important when you're up around 100 samples. As you can see very quickly, mathematically, the 1 isn't going to have very much influence on the square. It's going to be the difference of the square of 20 or the square of 19. So that isn't going to make very much difference in the result. But in very small samples, this correction for contingency here is important, because in very small samples, if I went through the mathematics, I could explain to you that there is some question of where the judgment might fall. And so a correction for that difference is necessary. We call that the correction for contingency, and we take off the minus 1. Well, now there are these chi-square values, of course. The more this sample is and the less this sample is, the higher this value is going to become, and the higher your chi-square is going to become. And the values for chi-square differ according to whether or not you're talking about a test for difference or a test for preference. We're only using these for preference, for difference in this case. And so the chi-square values, the minimum chi-square values for these tests are given in your text at the bottom of page, top of page. In a paired sample, when the difference is one tail, that is only one sample can be correct. If chi-square is equal to 2.71, if this answer is 2.71, it will be significant at the 5% level. If it's 5.41, chi-square is as much as 5.41, it's significant at the 1% level, 0.01. And if chi-square is 9.55, it's significant at the 0.01 level. So you simply calculate chi-square, and if it's as much as 2.71, that result would occur by chance only once in 20 times. 19 times out of 20, you would have detected a real difference in sugar between one sample and the other sample. If you find that chi-square is 5.41 or above, that result would occur by chance only once in 100 times, and 99 times out of 100, the person would not be guessing. He would actually be finding a difference in the sugar content between these samples, and by so forth for the 9.55. Well, setting up this test is not very difficult. Most people flip coins to decide which sample is going to be in the first position and which is going to be in the second position. The only thing I suggest that you don't do in setting up paired tests is decide that you will have a certain preconceived order of putting the samples, that you're going to have the first sample be sweet the first one and sweet the second one, and then not sweet or less sweet the next one, and less sweet the next one, and then sweet and less sweet and less sweet. This would be 2 of one and 2 of the other in the first position. The two glasses as they sit in front of you, this is the first glass and this is the second glass. If you do this, the smart panel will immediately decode your code, and they won't taste anymore. They'll just make, after they decide that this is the sweet one, the first 2 are sweet, then the next two they put less sweet, the next two they put sweet, and so forth, and the whole test breaks down. You have to assume that everybody is going to try and cheat on you when it comes to sensory evaluation. They're going to look for any clue they can have, and they will, whatever clue they can find, they will use. So any chance setup that you use, flipping coins to decide if it comes up heads, it's going to be the sweet sample in the first position. If it comes up tails, it's going to be the less sweet sample in the first position, and so on until you've got the required number of tests. How many paired tests does it take? For a single person, around 8 or 9. The tables will show you that it's better to have about 9 people in this test, but 8 will do. Some cases we even get by with 7 repetitions. But that means that paired testing cannot be done just on one sample, because if you only have one sample or one pair, you've got 50-50 chance of getting it right, and it doesn't prove a thing that you get it right. Now you can do another kind of a test, which we call multiple pairs, and there are a great many variations of this test that have been used. You tell them that there are just 2 samples. You tell them there are just 2 samples, one sweet and one less sweet, and that you're giving them 4 containers, 4 glasses. And they are required to pick out the ones that are sweet and the ones that are less sweet. This is called multiple pairs because there's 2 pairs and 2 pairs, 2 A's and 2 B's. And the various arrangements that these could be arranged, of course, and so forth. The only difficulty with this test is that it's more fatiguing, and it's very difficult to calculate the odds. But it can be done just the same as you can do a paired test. Some cases where you have very variable samples, people prefer, where the samples are not identical, where the A samples are not all exactly the same, and where the B samples are not all exactly the same, the multiple pairs type of test is used. We have not used it in the wine industry. Now, the next type of test is a true difference test also. It's called the duo-trio test. And it was specifically designed for blending tests. In the duo-trio test, a standard is presented first, and then 2 samples are presented. One is the standard, and one is not the standard. And the question asked in this one is, which of the 2 is the same as the standard? Obviously, it can be this one or this one, either one of those, X1 or X2. And the odds of getting the result correct are 50-50. There are a number of advantages which are apparent in the test, but which have not been borne out by experiments. The first advantage that you would think of is that you ought to get a larger amount of correct results by this type of test. Let's say the standard is the 1% sugar that we just had there. So this is 1%, and this is 1.3%. You would think that the odds of getting this correct, because there is a standard present and available for comparison, although not always continuously available, that they ought to get better results. But in actual fact, they don't seem to get any better results with this method in most testing as they do with this paired method over here. The reason, I think, is that you are doing 3 tests here as against 1 there. First, you're doing this test, the standard. Then you're comparing the standard with the standard. And then you're comparing the standard with the not standard. So you're making 3 different tests here. Whereas here you're only making 1. This one versus this one. So I think physiologically this may be a little bit more fatiguing, and psychologically may be a little bit more confusing than the specific question, which is the sweeter sample? Whereas this one may ask you which of these is the same degree of sweetness as the standard. So the question can be essentially the same in this test. But it can also be used for things where you don't know the difference. You have a blend. We'll say your X brand Burgundy, 50,000 gallons. And you have your old standard Burgundy that you've been selling for the last 3 months. And you make up this new blend. And the question arises in the winery, is the new blend the same or reasonably the same as the old standard that we've been using the last 3 months or the last 3 weeks or the last 3 days? Well, that type of decision can be measured by a duo-trio test. The odds are exactly the same as they are over here. That is, P can be, if P is as much as 1/20th, that's pretty good biological odds. We may prefer it 1 in 100, or if we had a national distribution and a lot of dollars were riding on it, I think I would require odds of 1 to 1,000. It is now true in this country that the duo-trio test is the most important sensory test that's being used in the alcoholic beverage industries. All American whiskeys and all Canadian whiskeys and most Scotch whiskeys coming on the American market at the present time go through a duo-trio test so that they can guarantee you that the teacher Scotch that you are drinking in California is exactly the same as the teacher Scotch that you are drinking in New York. And it's the same this year as it was last year. And it will be the same next year. This is true of all the big brands of American whiskeys. Is also true to a certain extent with some wines on the American market where these kinds of tests are being used. We've used the duo-trio test quite a bit here. There are no really difficult problems with handling it, any more than there are with the paired test. So we'll go on then to the triangular test, which is test that we started working on clear back in 1948, well actually in 47, right after the war. It's of interest to note that both of these tests, the duo-trio test and the triangular test, were developed by the alcoholic beverage industries. Not only developed by them, but for them. And but that's nothing new, of course. The whole analysis of variance and the whole t-test was developed by Fisher for the alcoholic beverage industries. The alcoholic beverage industries have perhaps had more influence on statistics than anything except the birth and death rates have had on statistics. In the triangular test, 3 samples are again presented, but none of them are specified as the sample, as the standard. The judge is told that 2 samples are the same, and 1 sample is different. And it's that word "different" that makes this test somewhat ambiguous. It's the same 2 samples. It's the same 1% and 1.3. Now there are 6 different ways that you could arrange these samples. You could put the 1% in these 2 and the 1.3 in these 2, or you could put the 1.3 in this one and the 1% in these 2, or you could put the 1% here, the 1.3 here, and the 1% over there. Or vice versa, you could put the 1.3, the 1.3, and the 1, or the 1, the 1.3, and the 1.3, or the 1.3, the 1, and the 1.3. Those are the 6 different arrangements that you can put 2 samples in 3 glasses. And that's the second problem of getting all those arrangements, utilizing all of those arrangements, 1, and 2, not getting the wrong wine in the wrong glass. When you've got 30 or 40 people are going to take a test, and each of them are going to get 5 triangles. You got 150 glasses you're going to be pouring into, and you got to get these 1%, 1%, and 1.3, 1.3 and 1 and 1. And it's very easy and surprisingly frequent that you'll get the wrong sample in the wrong glass and the whole test breaks down. So that unless you've got careful pourers who are not going to be lost by being hurried or anything like that, you better stay away from the triangular test. No specific difference is necessary again, as in the duo-trio test. You only are asking them which of these two glasses is different from the other. That is, it has some different characteristic. In this case, you could ask them which sample is the sample or samples are the less sweet and which samples are the sweetest. In this first case, the correct answer would be the glass, we'll call these glasses 1, 2, 3. The glass 3 is the different sample. The correct answer in the next one would be the first one, and the correct answer in this one will be the second. One of the advantages of the triangular test that's been much posed is that P is only a third. In other words, by guessing alone, you only get the correct result a third of the time. Whereas in the paired test and the duo-trio test, you get the correct result by chance half of the time. So that statistically, this is a more powerful tool than the other. But in actual fact, it hasn't turned out that way. The psychological problems outweigh the statistical advantages. The problem of getting confused. You compare the first glass with the second glass. Then you have to compare the first glass with the third glass. Then you have to compare the second glass with the third glass. So you have to make 4 different comparisons. And these comparisons tend to get people confused. They tend to get adapted and so forth. And they forget where they are before they get to the last comparison. Then they start all over again. And they forget which glass they picked up and so forth. So that the test is not proven as useful as we would like, but we will still use it, and we still do use it. It's very useful in detecting small differences in odor between samples. It's quite useful in detecting small differences in off odors. You have a group of people that say there is an off odor in this wine. Well, you take a wine that you know doesn't have an off odor, and you put it in a triangular situation and ask them which sample is different than the other two. And if they come up with the one that has the off odor, why then the test has succeeded. The calculation of the chi-square is more complicated than it is with the paired test or the duo-trio test, and so in most cases we recommend that you use the charts, which are given in the Hilgardia for this. But the chi-square is given there, and you can calculate it if you want. It's a little bit more complex to use than in the other sample. There's another disadvantage of the triangular taste test, and that's a built-in one of human beings. Human beings like to balance everything. They want everything to come out just even. So if you gave this test 100 times, and the odd samples had been exactly 33, this one was the odd sample, 33 was this one was the odd sample, and 33 was that one the odd sample, and you have somebody who has no ability at all to detect these, he will come up with, we'll say 25, oh, that's not quite, 30 is this one is the odd sample, and 30 that this one is the odd sample, but 40 that this one is the odd sample. Because that's the one that's balanced. The one in the middle is balanced between the other two. So when they can't find any difference, they will say that number 2 is the odd sample or the different sample, just by chance. In other words, there's a built-in bias for the middle sample being declared the odd sample or the different sample, even though it may not be. And that bias, of course, throws out the odds of P33, because the odds are no longer even on each one of the samples. So this is a fundamental statistical disadvantage of the triangular system. Now, we feel that it's not something that can't be overcome or that it rules out the use of the test. But where you're getting very fine differences and very small differences, you have to remember that this thing here is interfering with your statistical odds. And it may be necessary to go into a duo-trio or a ranking or a scoring or some other kind of system to get around this odds on the middle sample here. We've suggested various kinds of things to prevent it. For example, serving the samples that way so that no sample is the middle sample, hoping that visually they would do it. Or put them on a revolving table, which is constantly turning, so that no sample will be the middle sample, to prevent them from saying that the middle sample is the odd sample. The middle sample will be constantly changing in a revolving table that's going around. Well, this seems like an awful lot of work to get the same result that you can usually get in the duo-trio system. So the triangular system is not being used as much today as it was, say, 15 or 20 years ago. Well, we still have 4 minutes to go. Since we have another outline for the scoring thing, I will just briefly touch on ranking today, and then you'll get a new outline for Friday, which will cover the scoring. Ranking is the oldest method of sensory evaluation. It goes back to the 16th century. The odds for it have been developed a long time ago, and many different applications of it have been made. It's the one that most people like to use because he graduates in the top 10% of his class, the bottom 10% of his class. We are constantly subject to rankings of various kinds. At fairs, people make rankings on who made the best pie or the best cake, and rankings on who made the best wine, and so forth. Unfortunately, it's not very easy to rank things because it's very difficult to get a group of people to agree on what the sample should be ranked on. If I had made the experiment here, how would you rank a given sample of apple juice up here? And we'll make it a nice, modern, organic, cloudy apple juice. Well, all of those of you who are motivated by organic thinking would place that sample very high as against the next sample, which was a nice, clear, filtered Monterey County apple juice that's absolutely clear. And vice versa, those of you people who are prejudiced against cloudy apple juices and only drank clear apple juices would rank them exactly the opposite. In other words, you would have two different standards of what cloudiness in apple juice meant, and you would get two different kinds of results completely. We are all prejudiced on the basis of color, basis of appearance. We want our apple juice to be yellow, some of us. Some of us want our apple juice to be very light yellow. Others of it like to have it amber. Some of us don't mind if it's quite amber, and so forth. All of those factors are involved. Apple juice in Europe must be very light yellow in color, like a white wine. Apple juice in this country is almost always slightly amber. So there you would have a prejudice of the Europeans ranking apple juices as against American. Some people want their apple juice to be very sweet. Other people want their apple juice to be less sweet. And if you develop a scorecard for them that 50% of it's going to be the acidity and 50% of it's going to be the sugar and so forth, people will look at it different ways. So you have to train people for ranking. That's the point I want to make. You cannot give it to untrained people. And the people all have to agree upon what kinds of things they're going to use for the ranking. Otherwise, it will come out that there's no difference. Now, we know there's a difference between the cloudy apple juice and the clear apple juice. We know that they're different. We can see there's a difference between them. And so that we have to agree among us that we are going to have a certain amount of bias for one sample or the other sample in the ranking test. If you don't do this, you can't have very much confidence in the results. Also, when you get the samples ranked, 1, 2, 3, 4, you don't know how much difference there is between 1 and 2. 1 may be very good, and 2 may be very poor, and vice versa. So that's a big problem for you. Or you don't know that the one that you ranked first represents a gold medal, or whether it represents the rottenest sample in Stanislaus County or said county. So that there are all kinds of problems in ranking. Now, quickly, those people who might call out their names, if they'll come up and get the cards. Baker, Barnard, Beer, Bertram, Bird, Commons, Cronin, Dodd, Johnson, McDowell, Omoto, Palmer, Phillips, Richburg,